Hi, welcome. In this video, we will solve problem merge intervals asked by companies like Amazon, Facebook, Google, Apple, and Salesforce. Now let's check out one beautiful problem on intervals, merge intervals. Okay, so now let's check out this problem. So given an array of intervals where intervals I is equals to start of I and end of I. So basically this is my start point and this is my end point. Okay. Merge all the overlapping intervals. Remember, overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay. So here basically we have intervals array, right? This is my intervals array. And here some intervals are non-overlapping, some intervals are overlapping. We need to merge them and we need to create a series of non-overlapping intervals. Okay. This is basically a goal. So let's understand the first example here. So suppose we have one interval that is starting from 1 to 3. Okay. Then we have one interval that is starting from 2 and it is going till 6. Right. Some here. Okay. Then we have one 8 to 10 that is a non-overlap. So I will pick it here. Then we have one interval that is 15 to 18. So it will be somehow here. Okay. Okay. So now we are getting that we have this as an overlapping interval. Right. This is an overlapping zone, overlapping area. Okay, this is, we need to basically eh, reduce this overlapping. We need to merge them and we will get one interval that is from 1 to 6. Okay, then we have 8 to 10 and then we will have 15 to 18. Okay, similarly, right, we have two intervals 1 to 4. Okay, and one interval that is 4 to 5. Okay, same point 4 to 5. So what will the output of a total interval will be from 1 to 5? From 1 to 5. Okay. So these are basically our outputs, right? If I merge it, this will be my output. Here, if I merge it, this will be the output. So I hope you are clear with the problem statement, what basically the problem we have. Okay. Now let's see how we can solve this problem, what type of approaches we can apply. Okay. So let's take the same input, right? What was it? That is first interval starting from 1 to 3. Okay, and always try to create these type of a graph, you can say, or bar lines, so that we can clear the problem statement, right? We get the clarity of the problem statement. Okay, also we can come up with some new approaches, right? So we have one 8 to 10 and then we have one 15 to 18. Yeah, like this. Okay, and this will be an overlapping. Yes. So what will be the approach, how we can solve this problem? Okay. So let me first of all put this thing like how they have mentioned here, like exactly same. So we have one interval that is 1 to 3, then 2 to 6, then we have 8 to 10, and then we have 15 to 18. Okay. Okay. Now understand it. Okay. What we need to do, we need to, our goal is we need to basically, if there is an overlap, if there is an overlap, I need to merge it. Okay. So what will be my first task? That I need to reduce the overlap. I need to basically find the overlap. If I say the first time, I need to find the overlap. Where is an overlap? Okay. So the goal is find the overlap. And how I can find the overlap? Can you think here that this is an overlapping condition, but this is not an overlapping condition, right? So why this is an overlapping condition? Let's observe this one and this one, right? What is the difference between these two? So now let's check out the difference. So basically here you can see our end time, one interval, is greater than, right, start time. Can I say greater than equals to? Even if it is equals to one of the start time, okay, that is an overlapping condition. So can I directly say that my overlap is only possible, okay, when the end time is greater than or equals to the start time of the next interval. Start time of the next interval, right? Okay, this will be one condition. Let me put in a block. Now there is one problem with it. Okay, what is the problem? Let's see. Here the figure is something like this, and we are able to do it. Okay, like, and even like here, suppose instead of this, we are given with intervals like 1 comma 3. Okay, 2 comma 6. Sorry, 2 comma 6, and then we have 8 comma 10, and then we have 15 comma 18. Right. So I can say that yes, here these in these two intervals, right, there is an overlap because the end time, okay, is greater than the start time of the next interval, right? But suppose, right, the array is not represented like this, right? It is something, suppose 1 to 4, okay, and then we have suppose 5 to 7, okay, and then we have suppose 3 to 8, right? Why I'm saying this one, right? So basically we have let me represent it. We have 1 to 4, one interval, then we have one interval that is 5 to 7, and one interval that is from 3 to 8, right? So it is an overlap with 1 and 4 as well as 5 and 7, right? Okay, so that like the answer will be from 1 to 8, okay, if I merge it. But don't you think that it should come here, right? Because I will find that this is an overlap, okay, and what I will do, I will merge it, so it will become like the one interval will become from 5 to 8, right? Or suppose 3 to 8. I will write some condition, I will get 3 to 8. But still this is wrong, right? Because this is merging with the first interval too, right? It is merging with the first interval. So I need to sort it, right? I need to sort it. Here you can see the in this example when we have 1 comma 4, 5 comma 7, and 3 comma 8, this interval is basically sorted in their end time, sorted in their end time, okay, and this sorting in end time is not helping us, right? See, 4 end first, then 7 end, then 8 end, but it is not helping us. What will help us? If I sort this, if I sort this in their start time, that means like whichever interval will start first, okay, will come first. So if I sort it with their start time, 1 comma 4 will come, then if I take the next one, I will get 3 comma 8, and then I will get 5 comma 7, right? And then I will create, right, like here 1 comma 4. So this is an overlapping. So what I will do, basically what I will do is here the end time is greater than the start time, right? So the new interval will become from 1 to 8, okay, and then I have 5 comma 7. Again here the start time, the end time is greater than equals to start time. So what I will do, I will merge this two, and it will become 1 comma 8, right? Whatever the maximum from 7 and 8, right? So yeah, this thing is working. Sorting in starting time is helping us, but sorting in end time is not helping us. And remember, okay, I will give you one trick. If there is a question of intervals, okay, if there is a question of intervals, on the basis of intervals, always try to sort it. Sometimes sorting in starting time can help you, and sometimes sorting in end time can help you, okay. But after sorting, you will get some clarity, you will get some clear picture. You will I will 110% sure, after sorting you can, like, you there are more possible chances that you can come up with any approach. Suppose during interview you got a problem on intervals, right? If you tried sorting it, or you can explain also to the interviewer that I just want to sort according to the end time or a start time, you will get some clarity, right? The most probable chances are that you will come up with any approach, right? So always try to sort it, okay, maybe in the starting time or ending time. Here if I sort in starting time, it will help us. Here you can see this was also sorting on starting time. So I am getting this picture of overlapping. Even though like here's starting time and ending time both are same, but sorting in starting time will help us. Okay. Now, how many things we got from the observation? Here I have not discussed the approach. We are just discussing the observations, right? So one observation is end time is greater than the start time, and the second observation is sort in start time. Okay. So let's take one more example and let's understand the approaches more better. So let's suppose we have one example of 1 comma 3 one interval, then I have next interval suppose 2 to 5, then I have 1 4 to 6, then I have one interval from 7 to 8, and then one interval from suppose 9 to 12, and one 10 to 15. Okay, this is one interval. Okay, and basically same goal that we need to find if there is an overlapping condition, we need to merge them. Okay, so let's again create the diagram of it. So my 1 comma 3 will lie here. Okay, and first of all, like let me sort it according to their starting time. Okay, because we have observed this thing, so I will sort in starting time. So whichever will start first will come first. So 1 comma 3 will come first. Then we have, I guess, 2 comma 5. I guess these are all in starting time only. 2 comma 5, 4 comma 6, 7 comma 8 here. This is already arranged in starting time, but we should do it 9 comma 12 and 10 comma 15. Okay, now what I will do, I will try to create one figure and we will understand it. So we have from 1 comma 3, then I have 2 to 5. Okay, then I have 1 4 to 6, some here. Then I have 7 to 8. Then I have 9 to 12. Then I have 10 to 15. Yeah, these are my intervals. And what are the areas of overlap? This is an overlapping condition, right? Where end time is greater than the start time. This is an overlapping condition. Okay. Now, now how we are going to solve this, right? How we are going? We have so far we observed the only thing that if whenever the end time is greater than equals to start time, what I will do, I will say that this is an overlapping condition. Okay. Once this is an overlapping condition, right? Once this is an overlapping condition, because we have sorted in starting time, because we have sorted in a starting time, don't you think the merged interval, right? The merged interval, okay, basically there will be 2 points. Okay, basically there will be 2 points, right? A and B, this one as well as this one, right? Because we have merged it because we have sorted in starting time. Don't you think the first position will always be 1 here? Always, always. Like why I'm saying 1 here, see here, see, I am merging it, it will be 9 always. Why? Because I have sorted in their starting time. Okay, so which will start first? The first interval. So that's why I am putting in this first here. Here these two operations, right? First one and second one. Okay, overlap condition, which will come first? The first interval, right? Always, always. Whenever you are merging, the first interval will always come from the first time, because we have already done the sorted according to their start time. Okay, now what will come in this place? Okay, so this interval is going from 1 to 3, next interval is from 2 to 5, and there is an overlapping condition. So here I will get the max of 3 comma 5, right? Here I will get the max of 12 comma 15. So I can say the max of end time, okay, of the first one, end of first one or end of second. Basically this is the formula: max of end of first one and end of second one, right? Right. So here basically whatever the maximum is, so from 3 and 5, 5 is maximum, 5 will come. From 9 and from 12 and 15, 15 will come, right? And basically we will simply move ahead. I will simply move ahead. Okay. So now basically what is my approach here? I will find the overlap. Okay. If there is an overlap, I will simply figure out the merge interval and I will move ahead. I will move ahead simply. So what we can use here basically, now you can see this next interval I will compare with this one, right? I will compare with the this one that I have merged it. Then similarly this interval I will compare with the last one. Okay. So always see, this is the new interval, right? This is the new interval that I have merged. I will compare this one with this interval. Now when I am checking this one, I will compare this one to the next interval. Similarly, can I say that here we are checking with the most recent merged interval, most recent merged, or that is not merged. Okay. But most recent interval. Okay. So are you getting a sense of what I will so last in first out, or first in last out? So what is the first in basically in a stack? What like if there are number of items, one, two, three. Okay, which item will I will take out first? The most recent item that I have added, I will take that out first. Similarly, the most recent item that is merged or not merged, I will simply compare with that element. I will compare with that interval. So let's try to understand it much more better. Okay. So what was my figure? My figure was that I have an interval from 1 to 3, and then we have 2 to 5, okay, and 4 to 6, then 7 to 8, and then 9 to 12, and 10 to 50. Okay, so what I will do, I will create one stack and I will show you how, like, why I am getting this idea. Again, basically, as I you explained, the most recent item. Okay. So basically now see, okay, how I will do it. Again, we will check all these conditions, right? So suppose I am simply traversing through all my intervals, right? So this will be the first one interval, then second, then third, then fourth, then five, then six, right? I will traverse in this direction, right? So suppose I am at here, okay, first interval. What I will do, I will simply push into my stack. So 1 comma 3, I will push into my stack, right? Because the first interval you need to push always in the stack. I will push into this stack. The next I will go to the next interval and I will check is the end time. Okay. What is my peak element? This is 1 comma 3. Is the end time of peak element and starting time of the next interval, right, is greater? Like basically what was our overlapping condition? This was the overlapping condition. I will check this condition. So I will check this condition here. Is the end time is greater than the start time? So here, yes, end time, this end time, right? My peak elements, right? Peak element end time or peak interval end time. Peak interval end time is greater than the start time of ith interval, right? I pointer is at here. Green is pointing with the ith element, ith interval. So yes, peak interval end times is greater than equals to your starting time of an ith interval. So what I will do, again remember the formula that we have created, right? This position will be remain as it is, one will be always there, right? Remember, now end position will be changed, right? So what will be the position? Basically max of 3 comma 5, right? End time of first one and second one, end time of first one and second one. So 3 and 5, what I will do, I will simply, which is maximum 5, so I will update it with the 5. So I will remove this one and I will paste with 5, right? And I will simply move ahead. Now I will check again. Is the starting time here? Is the starting time here is less, like what was the condition? Ending time of my peak element, this 5 is greater than equals to starting time. Yes, it is, right? So what I will do again, what I will merge it, and how I will merge it, I will take the max of 6 and 5, which is maximum 6. So what I will do, I will again update it. Again, I will update it. So I will update it with the 6 and I will move ahead. Again, I will check, is the end time is greater than equals to start time? No, it's not. So what I will do, I will push this interval to my stack. So I will push 7, 8. Okay. And now my peak element will be here, peak interval. Again, now I will compare, right? I will compare here. Is 9 and 9, 12 is an overlap, right? So I will compare, is the end time of my peak interval is greater than equals to this interval 9 and 12? No, it's not. Okay. So what I will do, I will push this. So I will push 9, 12 as well, and my peak will move to the here. Okay. And my ith pointer will also move ahead. Again, I will check, is there is an overlapping condition? That means end time is greater than equals to the start time of the interval. Yes, it is. So what I will do, I will take the max of it. So max of 15 and 12, which is maximum 15. So I will simply put 15 here. Okay. Green. Right. And yeah, that's end of it. Okay. How many intervals I have? That is 3 interval, and these are my total intervals, right? So basically if I merge it, what I will get, I will get one interval that is from 1 to 6, then one interval from 7 to 8, and one interval from 9 to 15, right? And this is how we need to solve this problem. Okay, let's try to understand with one more example if we are building to the one approach. Okay, let me show you the same thing with one more example so that you are clear to apply with this code, and I hope now you can easily make your own code, but still I will tell you. So we have one from 1 to 4, then we have one from 2 to 7, okay, and one interval that is from 6 to 10, okay, and then we have one interval, suppose somehow here, that is from 5 to 9, okay, and let's suppose one interval 12 to 16, and one interval that is from 10 to 20, okay. So yeah, these are my intervals, and these all are, again remember, these all are sorted in their starting time. So these all are sorted in their starting time. Okay. So here I will simply create one stack. Okay. And I will start iteration. Right. And right, no matter what is the my first interval, I will simply throw into my stack. So 1 comma 4, I will simply throw into my stack, and I will start from here the next interval. Okay. Now, is end time of the my peak interval is greater than equals to the start time? Yes, it is, right? So what I will do, I will simply find out the max of it. So 1 comma 4 and 2 comma 7, which is maximum 7. So I will mention 7 here, right? And I will move to the next interval. Okay, that is 5 comma 9. Okay, so I will move it here. Again, remember, it's according to their starting time, right? This will come first. So again, is end time is greater than equals to their start time? Yes, it is. So what I will do, I will take out the maximum time here, 9 and 7, which is the maximum time, 9. So I will simply update with 9. Now I will move to the next one, 6 and 10, right? Is there is an overlapping condition? Yes, it is. I will take out the maximum, which is maximum, it is 10, and I will simply move ahead. Now 12 and 6, like 12, 16, this interval, and 1 comma 10. Is there is an overlapping condition? No, it's not. I will simply throw 12 and 16 here, right? I will move ahead. I will check 18 and 20. Is there an overlap? No, no overlap. I will simply push into my stack and I will move ahead, right? So basically, how many intervals I got? 3 intervals, and yeah, this will be my answer. One interval from 1 to 10, right? One interval from 12 to 16, and one interval from 18 to 20. These will be my intervals. Okay. Yeah. So this is basically this will be my approach, right? And now how we are going to implement it. So I will tell you in the implementation part how we are going to implement it. Till then, like if you want a mm, pseudo code, so let me give you the pseudo code of it. So here is the pseudo code. So basically what I will do, I will take one stack. Okay. You can simply say as result, right? We will create one empty array. Okay. And basically I will simply sort my all the intervals. So I will sort the intervals. Okay. According to their start time. Okay. So I'm not writing the complete code because it's difference in different programming. Again, that's a pseudo code. Then what I will do, I will simply write result dot push because I want to push the first element no matter what it is, right? So I will always push the first interval, that is suppose interval 0. Okay. And I will simply start a loop that will start from 1 to the intervals dot length, that is n. Okay. To this length. And I will check for an overlapping condition. Okay. Whenever my interval end time, right? So ith interval suppose starting time. Okay, here you can simply mention if interval starting time is less than or equals to basically what I was saying peak element. So let me mention that peak element only. And for that, let me define one pointer as well. So suppose I have current pointer that is pointing to result last element, right? Peak element. So current is basically suppose the result dot length -1, right? So it will point to here 0. Okay. Now my peak element, right? My peak element result current, right? Result of current comma 1 because end time is greater than equals to the intervals I time, intervals I comma 0 starting time. Okay. Then what I will do? Then I will change what? I will change the result end time. And what will be it will be a max of two things, right? So max of intervals ith time I comma 1. Okay. Or it can be result of current comma 1, right? Whichever is maximum, it will be this value. Now after this, right, if suppose there is not an overlapping condition, then what I will do, I will simply put else condition. Okay. And I will simply push it to my result. So result dot push the interval. So I will simply push the intervals I. Okay. And I will move my pointer also. So current pointer will be again peak element. So it will be result dot length -1. Okay. And in the last, I will return the result. Yeah. Sorry for the bad handwriting. I am not used to it, but yeah, that's a pseudo code. So I have written like this. So basically you are sorting here, right? If you are taking like very efficient sorting, so it will take around big of n log n. So here I am discussing the time complexity. Okay. And this will run for how many times? N minus 1 time. Okay. Because you are starting from 1. So the time complexity uh, will be n log n plus n minus 1 time, right? Now, whichever the maximum is, right? N log n or n minus 1, that will be the maximum time, right? So here n log n is the maximum. So the time complexity will be big O of n log n. Okay. I'm ignoring this one because this is maximum. I will take the maximum of it, right? So basically, I will take n log n. Otherwise, the total time complexity will be big O of n log n plus big O of n. But if I'm like ignoring that one because I will take the maximum, so it will be n log n. So yeah, this will be the time complexity. What about the space complexity? So in the worst case, there can be one thing that there are no overlapping intervals, right? All the intervals are non-overlapping. So you will push all the elements into your resultant array, right? So basically your space complexity will be big O of n, right? So thinking about the worst case, right? The space complexity is big O of n and time complexity will be big O of n. Yeah. So yeah, this is the pseudo code of this problem. In the next video, I will tell you about the code implementation of this problem in the JavaScript. Okay. So check out the next video for the code implementation part, and then we will see the dry run. Okay. Yeah. Then bye bye.